Um, Now let me just step back from specific code examples and talk a little bit more about union types and where you might use them and how you've seen them before and what you've done. So more examples of union types. You might have some data type that is a string or a number. Okay. Here's a very common thing that happens in my Java programs. I'm like, hey, I either have a real string or I have null, and that's sort of part of my logic, part of what I'm trying to represent. So, it might be an error message, or if there wasn't an error, null. Okay. Okay, here's another time when I might use a union type. I might have a course result is either a number, a number of grade points between 0 and 4. Okay, it could be the symbol incomplete. It could be the symbol in progress, or if it's something you're planning on taking a future semester, it might actually be a string of the planned semester. So yeah, this is a number or a string or a couple of different kind of sentinel values. Okay. How about a card rank? A card rank can be a natural number in the range 2 up to 10. Maybe it can be one of the symbols ace, king, queen, jack. And then maybe jokers. Your card games might have that as a really kind of a separate category. So yeah, again, I would view this as it's a little bit unclear if this would be considered a union type with 3 branches, or should this really be 4 different branches, kind of like we did in enumerated types. And yeah, I can go either way on that, but okay. Functions, often you might have a function that takes in a color spec, and the color spec might be the name of the color, or it actually might be the RGB values. So this happens all the time in, say, HTML, right? You can actually use either one. The programs that handle that, the browser has to handle, hey, I'm either getting a string or these RGB numbers at some level. So, and I have to be able to have my functions that can handle both of them. That's a union type. A date might be a string or a day number of the year, or it might be an actual object with a bunch of fields. And maybe if a function wants to take in a date in any of these representations. That's a union data type right there. Okay. A problem report could be a natural number that might be an index into your database, or the ID number of the existing problem. Or if it's a brand new problem that's being submitted, maybe it's the string, the actual problem report. Okay. And you need to be able to handle both new reports and existing reports. And you have functions that want to handle both of them. In Java, it's hard to say. I have a function that takes in either a natural number or a string. So, okay. A few more motivating examples where you might have or want to have a union data type. I wrote a program dealing with file processing a while ago, and I found that really I wanted to be able to either have the name of a new file or an existing file that I was in the middle of processing, so an open file port. And so it's very common to write code that wants to be given an existing open file port, or, which might be an object of type file in Java, or it might be the name of a file that is to be opened and used. Okay, so yeah, you could use that. And finally, a transaction. A transaction might include different ways of paying. And you might pay in cash, you might pay with a check, you might pay with a credit card. Well, if you pay with a check, maybe you will note the check number. If you pay with cash, we'll just note how much, maybe there's a cash discount we gave. This is all going to be separate from maybe the amount. That might be common in all of these. And then if you have a credit card, yeah, you want to know what is the credit card number, what is the expiration date, things like that. So you might have to keep several pieces of information. But you would have a union of these different sort of things that are all a valid transaction. How do we do these in Java? And the answer is a little bit of a mix. So the biggest thing I'll mention is some people say, oh, you have a function that wants either a string or a number. That's no problem. Well, I can do that in Java. I can overload my functions. I write foo that takes in a string, and then I have another method foo that takes in a number. And it's overload. Yeah, overloading does allow you to handle union types when you pass them into a function. But there's no way to return a union type from a function. Okay, so if you have a function that's supposed to be returning one of these things, yeah, then it's not so easy. Okay, at least not built-in easy. We'll see a solution. String or null, and this is sort of, people use null all the time. Why do people use null as a sentinel value in Java? Because null type checks as a string. If you have a variable type string, you can assign null into that variable. Okay, if a function is supposed to return a string and it returns null, Java lets that happen. That is both, maybe that's convenient. It's also awfully annoying because when I'm looking at Java code and I say, oh, hey, here I have a variable s of type string, so it holds a string. No, it doesn't. It does not hold a string. It holds a string or null. Yeah, and you need to remember that all the time. Every time you get a null pointer exception, it's because the programmer forgot that string does not mean string. String means string or null in Java. Oh, yeah. Also, null is fine if you have one sentinel value, but it's not good if you have multiple sentinel values, like the incomplete and in progress. That's two different sentinel values down for the course result. Okay. Also, I should say that null sometimes, having this null as your sentinel value used all over the place, not unreasonable. But there are weird situations where, say, Java util map, you've associated a name with some sort of other string. Well, it might be associated with a string or null. And now you do look up in that hash table, look up in that map. And if you get null back, it could be that, yeah, you found the name, it was in the hash table, and it returned null because that was the value associated with that. It turns out in Java util map, they say, well, we need a sentinel value for here's the result, or we didn't find the result. We'll use null as that sentinel value. So you actually don't know. It might be a reasonable choice to use a string or null in one place. That's a type you can't put into Java util hash map, a nullable string, because when you try to get something out of there, at least it becomes more complicated. You can't use the simple thing. Other people are using null as a sentinel value that interferes with your sentinel value. We should have had a data definition that really gave us that union. So, okay. So Java lets you do some things. Null is a common way. It's really a simple example of a union type that is people use in a hacky way and it doesn't extend and has its issues. You can use overloading. That helps with union types as inputs to a function, but can't be used as a return value. But I think what does become clear at the very end, if I go and look at this last one, this transaction, and I wanted to have a Java function that returns a transaction. So it might be a double, it might be an int, it might be a string and 2 ints. What would I have to do in Java? And we'll come and actually do this a little bit later. I could go ahead and make a class transaction that is abstract and have, for each of these three variants in my union type, I could have a subclass. Class cash transaction extends transaction, cash check extends transaction, cash credit card extends transaction, and each of those can be objects with fields, so the credit card fields can be inside that credit card. It is and I can now say, hey, my method returns the transaction, and the polymorphism that object-oriented provides lets me have a union types like that. I'm still jumping through some hoops. So if I just had a double, I'd have to have, I can't say class double extends transaction because class capital D double is already defined in Java. I'd have to make my own class, cash transaction with a single field in it that's a double. And it's a little bit, the type system is now making me jump through hoops to do what I want. So, okay, so those are some thoughts on union types and when you might use them. The important part is we have this design recipe, and we include a template for union types. If you notice, this is step 3A. We still have steps step 3B and 3C to look at, and we still have step 6 to keep us in suspense. I'll see you later.